You see this blurry smudge in the sky? For thousands of years, the smartest people on Earth thought it was just a cloud in our own galaxy. They were completely wrong. This isn't a cloud, it's a monster galaxy with 1 trillion stars. And the craziest part? It's flying directly at us at unimaginable speed. Today, we are going to the Andromeda galaxy. So what's hiding inside this absolute beast? Its arms are literally factories that are building millions of stars. But in the center, there's a supermassive black hole that makes ours look like a pebble. This galaxy's future is our future, and what's coming is going to be insane. This is Andromeda, and I'm going to show you exactly what's going to happen to our home, the Milky Way. Section 1. The Great Discovery. For literally centuries, the smartest people on Earth stared at this thing and just called it a little cloud. I'm not even joking. One guy, Messier, gave it the super boring name M31 because he thought it was just some gas in our own galaxy. For the longest time, everyone just assumed the Milky Way was the entire universe. They thought this was IT, but some people knew something was up. This started a massive argument called the Great Debate. On one side, you had Team Shapley, saying things like Andromeda were just gas inside our galaxy. On the other, you had Team Curtis, who argued they were entire island universes, galaxies just like ours. Curtis saw that exploding stars in Andromeda were way dimmer than ours, which could only mean they were much, much farther away. The whole debate was at a total standstill. Was the universe just our galaxy, or were there billions more? Then, this guy Edwin Hubble came along and changed everything. In 1923, he used the biggest telescope in the world to find special stars called Cepheid variables. These stars are basically cosmic measuring sticks. They pulse, and how fast they pulse tells you their true brightness. That means you can figure out exactly how far away they are. And he found them. Hubble did the math, and the number he got was absolutely insane. Andromeda wasn't a few thousand light years away. His calculations showed it was almost 1 million light years away, and today we know it's even farther, 2.5 million light years. It was a completely separate galaxy. In that one moment, our universe got billions of times bigger. The Milky Way wasn't alone. That little smudge wasn't just a cloud, it was our sister galaxy, and its discovery launched modern astronomy forever. Section 2. The journey begins, scale and distance. Alright, let's start this journey. The first thing you need to realize is how insanely empty space is. Andromeda is 2.5 million light years away. You can actually see it without a telescope if you're in a super dark place. It is the farthest thing a human can see with their own eyes. So what does 2.5 million light years even mean? The light from Andromeda that is hitting your eyes tonight started its journey when the first humans were walking on Earth. You are literally looking 2.5 million years into the past. I'm going to give you a crazy analogy. If the Milky Way was the size of a dinner plate, Andromeda would be another, bigger dinner plate 25 feet away. Everything between them is just empty space. Our fastest rocket would take billions of years to get there. As we fly closer, that smudge just explodes into this unbelievable galaxy. The first thing that hits you is the sheer size. Andromeda is the heavyweight champion of our local group, which is a crew of over 50 galaxies. Its main disk is 152,000 light years across. If it were brighter in our sky, it would look 6 times wider than the moon. Can you even imagine that? Our galaxy has around 400 billion stars, which is a lot. But Andromeda has 1 trillion stars. That's 1,000 billion suns. For years, we thought that made it way heavier than us. But in a crazy plot twist, scientists now think the Milky Way might actually be denser because it has more dark matter, making us the heavier galaxy. It's bigger, but we might just be beefier. Section 3. Exploring the galactic metropolis. We've arrived. As we get to the edge of Andromeda, its structure is unreal. We used to think it was just a normal spiral galaxy, but the newest telescopes showed us it's a barred spiral galaxy, just like us. That means its arms don't come from the center, they shoot out from a giant bar of stars running through the middle. From out here, you can see these incredible arms sweeping around. They aren't solid, they're basically giant cosmic traffic jams where gas gets squeezed together, kicking off insane bursts of star-making. These are the galaxy's star factories, glowing with brand new, super hot stars that burn out incredibly fast. But look closer, Andromeda's structure is wild. It has these giant, overlapping rings of dust. They even nicknamed one the Ring of Fire because so many stars are being born there. Astronomers think these rings are battle scars from a galactic collision hundreds of millions of years ago, probably when a smaller galaxy smashed right into it. Okay, we're leaving the suburbs and heading downtown, into the galactic bulge. The number of stars here is absolutely mind-blowing. And these stars are different, they're old, they're red, and they're all flying around in total chaos. This is the ancient heart of the galaxy. Section 4, the heart of the giant. We are now at the absolute center of Andromeda, and things are about to get weird. As we get close, you see the core isn't just one bright light. The Hubble telescope showed that it looks like it has a double nucleus, with two bright spots named P1 and P2. So, did two galaxies smash together and leave their cores behind? No. The real answer is even crazier. The true center is the dimmer spot, P2. The brighter spot, P1, isn't another core. It's a massive clump of old, red stars orbiting the center at a super weird angle, and nestled inside that is another off-center disk of young, bright blue stars, all swirling around the same single, invisible point. It's just complete chaos. A clump of old stars and a disk of new stars, all trapped by the unbelievable gravity of the core. How those young blue stars even formed there is a huge mystery that no one can solve. What looks like two cores is really just an optical illusion created by star clusters orbiting one monster object. So what is that object? What has enough power to control all of this chaos? Section 5, the monster within. The stars here are moving at unbelievable speeds, way too fast to be held by the gravity of other stars. There's only one explanation, a supermassive black hole. They call it M31 star. And when I say supermassive, I mean it. Our galaxy's black hole, Sagittarius A*, is 4 million times the mass of the Sun. That's huge. But Andromeda's black hole is 100 million times the mass of the Sun. It's an absolute titan that makes our black hole look tiny. Even though it's huge, this black hole is surprisingly quiet. It's not shooting out energy everywhere, it's more like a sleeping giant, but it's still eating. We've literally seen gas getting sucked into it like cosmic spaghetti. It's just having a slow, steady snack. But that's not the only black hole here. In a crazy twist, scientists found another one, not in the center, but inside a giant star cluster called Male 2. This one is an intermediate mass black hole, 100,000 times the Sun's mass. This was a massive discovery. For years, we could only find tiny black holes or supermassive ones. This could be the missing link that shows how the giant ones get so big, by swallowing the smaller ones. Section 6, a cannibal's past. You don't get a trillion stars by playing nice. Andromeda got this big by being a cannibal. For billions of years, it's been smashing into smaller galaxies and eating them. When it does, its gravity rips them apart, stretching their stars into these long, faint trails called stellar streams. If you look around Andromeda, you can literally see the bones of its last meals. We've mapped out these giant, ghostly streams of stars all around it. Every single one is a dead galaxy that got too close. And the feast is not over. It's got dozens of smaller galaxies trapped in its gravity right now, like its famous companions, M32 and M110. Their fate is sealed. Eventually, they're going to get pulled in, torn apart, and their stars will make Andromeda even bigger. This is how giant galaxies are made, and it's setting up the biggest cosmic event in our future. Section 7, the dramatic twist. For over 100 years, we've known something terrifying. Andromeda is coming straight for us. While almost every other galaxy is flying away, this one is headed right for us at 400,000 kilometers per hour. That's so fast, you can't even process it. For years, the prediction was a simple, head-on crash in about 4.5 billion years. They even gave the new galaxy a name, Milkomeda. But wait, there is a huge plot twist. To predict a crash, you also need to know its sideways motion, which is almost impossible to measure from 2.5 million light-years away. But then, the European Space Agency's Gaia spacecraft, this insane satellite, changed the game forever. It was so precise, it could track the tiny sideways drift of Andromeda's stars. And the new data shows a head-on collision is probably not going to happen. Instead, it looks like we're going to have more of a glancing blow. Some simulations are now saying there's only a 50-50 chance of a merger in the next 10 billion years. The two galaxies might just fly past each other and do this insane cosmic dance for billions of years before finally becoming one. So what happens if they do collide? Because space is so ridiculously empty, almost no stars will actually hit each other. Our solar system would probably survive, but we'd be thrown into a crazy new orbit inside this new supergalaxy. For anyone on Earth 4.5 billion years from now, the night sky would be the most incredible show ever, with giant streams of stars lighting up the view as the two galaxies merge into one. The fact that this entire story changed in just a few years is completely insane. Science is moving so fast. If you want to go on more of these crazy cosmic journeys, smash that subscribe button and click the notification bell so you don't miss a single video. And I am giving you a challenge. If these two galaxies do merge, what should we call the new one? Andromeda is okay, but I know you guys can do better. Give me your best names in the comments below. The best one gets bragging rights forever. Conclusion. As we fly back home, Andromeda turns back into that majestic island of light. But now we know it's not just a pretty picture. It is a living, breathing system of creation, destruction, and insane change. Andromeda is more than just our neighbor, it's like looking into a cosmic mirror. By studying it, we learn about the crazy forces that built our own galaxy. It's also a crystal ball that shows us our own future. This insane dance between our two galaxies is the next great chapter in our cosmic story, whether they crash or just miss each other. This is the ultimate proof that the universe is not some quiet, boring place. It's a wild, evolving battlefield where even something as big as a galaxy can be born, crash, and become something completely new. From a tiny, blurry smudge to a city of 1 trillion stars, Andromeda taught us our true place in the cosmos, and it dares us to keep looking up.